Hello everyone, welcome to eTech YouTube channel. In this video, we will see an introduction to an external gear pump and its working mechanism. What is an external gear pump? An external gear pump is a type of positive displacement pump that moves fluids by trapping them between rotating gears and the pump casing. Its simple design consists of two gears: the driving gear connected to a motor and a driven gear which mesh together within a housing. As the gears rotate, they create a vacuum at the inlet side, drawing fluid into the pump chamber. The fluid is then carried around the gears and forced out through the discharge port. Known for their efficiency, reliability, and versatility, external gear pumps are used in hydraulic systems, lubrication systems, fuel transfer, and chemical processing, among others. How does an external gear pump work? External gear pumps work on the principle of positive displacement, meaning they deliver a fixed amount of fluid for each revolution of the gears. Here's a more detailed explanation of how they work. External gear pumps consist of two gears, a driving gear, connected to the motor, and a driven gear. These gears have precise teeth that mesh together and rotate within a close-fitting housing or casing. As the gears rotate, they create a low-pressure area at the inlet side of the pump. This low pressure causes fluid to be drawn into the pump chamber from the fluid reservoir or inlet port. As the gears continue to rotate, the fluid is carried around the outer periphery of the gears. The fluid is trapped between the gear teeth and the pump casing, preventing it from flowing back to the inlet side. As the gears rotate further, the trapped fluid is carried to the discharge side of the pump. The increasing volume between the gear teeth and the casing forces the fluid out of the pump through the discharge port. This process repeats with each revolution of the gears, delivering a consistent flow of fluid. The flow rate can be controlled by adjusting the speed of the motor driving the pump or by changing the size of the gears. External gear pumps rely on tight clearances between the gears and the pump casing to minimize internal leakage. Seals are also used to prevent fluid from leaking out of the pump and to maintain pressure within the system. External gear pumps are used in a wide range of applications where precise fluid delivery is required, such as hydraulic systems, lubrication systems, fuel transfer, and chemical processing. Main components of an external gear pump. The main components of an external gear pump include driving gear, also known as the input gear. This gear is typically connected to the motor or another source of mechanical power. The driving gear transfers rotational motion to the driven gear. Driven gear, also called the output gear, it meshes with the driving gear and rotates as a result of the driving gear's motion. The driven gear transfers the rotational motion to the fluid being pumped. Pump casing. The pump casing, or housing, encloses the gears and provides a chamber for the fluid to be pumped. It also contains the suction and discharge ports for fluid entry and discharge. Suction port. This is the point where fluid enters the pump. It is typically located on one side of the pump casing and allows fluid to be drawn into the pump chamber as the gears rotate. Discharge port. This is the point where fluid exits the pump. It is located on the opposite side of the pump casing and allows the pumped fluid to be discharged from the pump. Bearings. Bearings support the gears and allow them to rotate smoothly within the pump casing. They help reduce friction and wear, contributing to the pump's efficiency and longevity. Shafts. Shafts connect the gears to the driving source, such as a motor, and transmit rotational motion from the driving gear to the driven gear. Advantages of external gear pump. External gear pumps offer several advantages that make them suitable for various applications. Simple design. External gear pumps have a straightforward design with relatively few moving parts, making them easy to understand, operate, and maintain. High efficiency. They are known for their high efficiency due to minimal internal leakage and tight clearances between the gears and the pump casing. This results in less energy loss and greater overall efficiency. Positive displacement. External gear pumps provide a constant flow rate for each revolution of the gears, making them ideal for applications requiring precise fluid delivery. Wide range of fluid compatibility. They can handle a wide range of fluids, including viscous liquids, corrosive chemicals, and abrasive slurries, making them versatile for various industrial and commercial applications. Self-priming capability. External gear pumps can often self-prime, meaning they can evacuate air from the suction line and start pumping fluid without the need for external priming devices. Compact size. They typically have a compact footprint compared to other types of pumps with similar flow rates, making them suitable for installations where space is limited. Disadvantages of external gear pump. While external gear pumps offer numerous advantages, they also have some limitations and disadvantages. Limited high-pressure capability. External gear pumps are generally not suitable for high-pressure applications compared to other types of pumps like piston pumps or multi-stage centrifugal pumps. They may experience performance limitations or require additional equipment for boosting pressure. Limited suction lift. External gear pumps may have limitations in terms of suction lift capabilities, especially with viscous fluids. This can restrict their suitability for certain applications where a high suction lift is required. Risk of cavitation. In some operating conditions, external gear pumps may be susceptible to cavitation, which can lead to decreased pump efficiency, increased noise, and potential damage to pump components. Wear and tear. The close tolerances between the gears and the pump casing can lead to wear over time, especially when pumping abrasive fluids or under high-pressure conditions. Regular maintenance is essential to address wear and prevent pump failure. Temperature sensitivity. External gear pumps may not be suitable for pumping fluids at extreme temperatures, as high temperatures can affect the viscosity of the pumped fluid and potentially damage pump components. Thank you for watching. If you found this video insightful, do give it a thumbs up and subscribe for more intriguing content. And remember, if you have any questions or thoughts, feel free to drop them in the comment section.